video is on chapter 18, lesson number 4 on z-scores and standard normal distribution. A z-score is a value that shows how many standard deviations a data value is from the mean. When the z-score is positive, the data value is above the mean. When the z-score is negative, the data value is below the mean. When z is equal to 0, the data value is equal to the mean. So I'm going to try to explain what's happening here, but I need the picture of our normal distribution from our last set of notes. So that's what I'm showing you right now, but I'm just using the normal distribution curve. In the normal distribution curve, you know that the mean of the data is the center. And then depending on whatever that number is and whatever your standard deviation is, you are able to fill in these data points on your curve. So basically what's happening in lesson number 4 is, what if I don't have one of those numbers? What if I have a number that falls in between that one standard deviation away and that second standard deviation away? What we do is find the z-score, and the z-score tells you how many standard deviations you are away from the mean. When that z-score is positive, that means that whatever that data point is was above or to the right of your mean. If the z-score is negative, then that means that your data point is below or to the left of the mean. So hopefully this makes a little more sense what those bullets mean. So the z-score formula, to find the z-score for a data value in a set that is normally distributed, you're going to use this formula. Z is equal to x minus the mean divided by the standard deviation. So Z is your z-score, x is the data value. And again, the mu is the mean, and then sigma is your standard deviation. So let's look at some of these examples. In this first set, it says a radar detector records the speed of a group of cars that passes by. If the mean is 46 miles per hour and the standard deviation is 2.8 miles per hour, find the z-score for each data value. So I'm going to look at A. What we're asking here is I need the z-score for my data point, which is 52. So using the formula that you're given, we're finding the z-score. The x is the data value, which is the 52, minus the mean. And in my word problem here, it says that the mean is 46. And we're going to divide by the standard deviation, which is 2.8. So you would go to your calculator and you would do the 52 minus the 46 and then divide that by the 2.8. And that's going to give you 2.14. Now, what does that mean exactly? What that means is that 52 falls 2.14 standard deviations above the mean. So if you think in terms of your normal distribution, it's a little bit past that second standard deviation away, to the right, above the mean. Let's look at example B. Same thing. I want to find the z-score. My data value, which is x, is the 42, minus the mean, which is the 46. And again, I'm dividing by the standard deviation of 2.8. So 42 minus the 46, and then again dividing by that 2.8 gives me negative 1.43, which tells me, because it's negative, 42 falls below the mean, and it falls 1.43 standard deviations below the mean. In the next 3 examples, what we have are word problems using the formula. The z equals x minus mu over sigma, or mean over standard deviation. Using that formula, we're going to plug in some information and try to find what's missing. So in example 3, it says the mean number of total miles ran last week by each member of the track team was 4, with a standard deviation of 1.2. If Clay's z-score was 2.5, how many miles did he run? So by them asking us how many miles did he run, that's the x. So the z-score, filling in for z, I got 2.5 equals, I'm looking for x, minus the mean, which is 4, over the standard deviation, which is 1.2. So to solve this, I would multiply by 1.2 on both sides. 1.2 times 2.5 is 3. So now it says 3 is equal to x minus 4. And when you add 4 to both sides, you get x is equal to 7. So he ran 7 miles. The other example that I want to look at is example number 5. The height of a group of trees is normally distributed with a mean of 14.3 feet. If the z-score for a 20-foot tall tree is 1.9, what is the standard deviation? So z is 1.9. My data point is the 20-foot tall tree minus the mean of 14.3. And I'm dividing by the standard deviation because that's what I need to find. So in this instance, I would multiply both sides by the standard deviation to get 1.9 times the standard deviation. And then 20 minus 14.3 is going to be 5.7. And then you would divide that by the 1.9 and get 3. So the standard deviation is equal to 3. All right, let's move forward in our notes here to standard normal distribution. A normal distribution in which, so let me back up. For standard normal distribution, what that means is it's normal distribution where the mean is always 0 and the standard deviation is always 1. The distribution is standardized by the z-score. What we're going to do here in these next few examples is we are going to use the calculator to calculate the area under the curve that is above or below our z-score based on the question that's being asked. So the first thing that we need to do is we need to set up our calculator so that our window is right. Okay, so I'm going to go to my calculator and I'm going to go to window. And there's 3 things that you need to make sure that you've got, actually 4 things that you've got going on here. The x min needs to be -4, which I already have. The x max needs to be a +4, which I already have. Do not change the x scale, just leave it as a 1. Your y min needs to be 0, and your y max needs to be 0.5. The rest of this does not matter. You're going to leave it alone, okay? So then I'm going to talk in just a second about these steps. And I want to first read you the example that we've got going on, and then we're going to work a couple of these questions. The golf scores in a tournament is normally distributed with a mean of 76 and a standard deviation of 2.6. And then it says find each probability. So for question number 6, it's asking me to find the probability that the z-score, when the z-score is less than 2.1. Okay? So we, again, are going to use our graphing calculator, and you can kind of see over here on the left what that might look like in the calculator. Okay? So to do this, to calculate this probability, this percentage, you first have to find the z-score, which we have. Z is going to be the 2.1. actually, let me back up, because on a normal distribution curve, let me go up here. I forgot to mention that you have a positive infinity out on the right and a negative infinity out on the left. So basically what we have to do is we have to set up a range for the calculator to calculate where that area is going to fall to find that percentage. And there's not a symbol in the calculator for positive infinity or negative infinity. So for positive infinity, you're going to use 1 times 10 to the power of 99. That's the closest we can get to infinity in the graphing calculator. Well, we can't write it like that. We cannot put it into the calculator. The calculator has a shorthand for the times 10 part. It's 1 and then the capital E and then the 99. And I'll show you where that is in the calculator here in just a second. Negative infinity is exactly the same, except for you need a negative 1 times 10 to the 99th power. So that is as close to positive infinity and negative infinity as we can get. Now, let me go back to question number 6. So again, step number 1 that I've given you here is find the z-score, which in question number 6 is going to be the 2.1. The second step says to hit second and then vars. So second vars is to the left of clear. The next step, if you look at your paper, it says to arrow over to draw. So I'm going to arrow over to draw. Step 4, select number 1, shade norm. So this is where we need to set up our lower boundary and our upper boundary. So I'm going to go back to our paper here. And this says the probability that the z-score is less than 2.1. Well, if it's less than 2.1, then we're going to be heading towards negative infinity. So my lower boundary needs to be negative infinity, which it already is. My upper boundary is going to be that z-score of 2.1. So I'm going to put the 2. Oh, nope. I forgot to arrow down. Hang on. So negative 1 times 10. So your times 10, your E is second, and then the comma, which is just above the 7, and then the 99. And then I'm going to put in my 2.1 for my upper boundary. You never want to change the mean or the standard deviation here, because this is a standard normal distribution. And in a standard normal distribution, go back to the notes, in a standard normal distribution, that is where your mean is 0 and your standard deviation is always 1. So in the calculator, we're going to leave that. I'm going to arrow down to draw and hit enter. Now what's going to happen is the calculator is going to draw exactly and fill in the area under the curve that represents all of the data points that are less than the z-score of 2.1. So it tells you here that the area is 0.98214. So 0.98214 is the area. As a percent, that's 98.21%. So what that means is 98.21% of all z-scores fall below 2.1. Let's look at example number 7. The difference between example number 6 and example number 7. Actually, you know what? Let me do example number 9 because it's a greater than. In example number 9, the biggest difference here is you don't have the z-score. You have x is greater than 81. What is the probability that your data value is greater than 81? So before we can do anything, we've got to calculate the z-score. So calculating the z-score, we've got our data point, which is 81, minus the mean. They give us that in the information up here, minus 76, divided by the standard deviation of 2.6. I'm going to go back to my calculator. I'm going to quit this. Again, 81 minus the 76, and then divide by the 2.6 gives me a z-score of 1.92. So 1.92. So I'm going to need that 1.92 in my calculator. So I need the probability that the z-score is greater than 1.92. Okay? That's what we're looking for. And again, we're going to use the calculator to do that. Greater than 1.92 is going to be going towards positive infinity. So our lower boundary here should be the 1.92, whereas the upper boundary is going to be positive infinity. Back to the calculator. Second vars, arrow over to draw, enter. Now I just said our lower boundary here needs to be the 1.92. So 1.92. My upper boundary is positive infinity. So 1 times 10 to the 99th power. Again, leaving the mean and the standard deviation alone. I am going to change my color. Lesson learned, it doesn't erase the color. It doesn't erase the shading. So I just change my color each time. And then I'm going to hit draw. You can see here that I changed it to pink or magenta. So that this gives us a very small portion here. So the area on the pink area is represented by the 0.02743. 0.02743. Which as a percent is 2.74%. All right, so that leaves me with number 10 or number 11. I'm going to do both. So on number 10, we've got what is the probability that your z-score is going to fall between negative 0.2 and a positive 1.8. So again, I already have the z-score here. I do not need to calculate it. But I am going to go to my calculator, and I'm going to hit second vars, and I'm going to arrow over to draw and shade norm. Okay, so let me go back. So the cool thing about this is my left boundary, and then the 1.8 is my right boundary, or my upper bound. My lower bound is negative 0.2. My upper boundary is 1.8. So for my lower boundary, again, we're going to put in the negative 0.2, and the upper boundary is the 1.8. I'm going to change my color again, just so you can see the difference here, and then hit draw. So the green represents the area, which is 0.54333. So 0.54333, which is 54.33%. The only difference between 10 and 11 is, if you'll see here, it asks me the probability that the X falls between 77 and 83. So we have to calculate the z-score for both of those numbers. So real quick, to find the z-score for the 77, it's going to be 77 minus, the mean is still 76, and the standard deviation is still 2.6. So that's going to give me a z-score of 0.39. And then for the 83, let me count that really quick. 83 minus the 76 divided by 2.6. And when you put all that in the calculator, you're going to get 2.69. So the extra that you have to do on problems like 9 and 11 is you have to calculate the z-score first. So the 0.39 is my lower boundary. The 2.69 is the upper boundary. So going back to my calculator, second vars, arrow over to draw, shade norm. Again, the lower boundary was the 0.39. The upper boundary was 2.69. And again, I'm going to change my color so you can see exactly what's being shaded here in orange. The 0.3447 is equal to 34.47%. So there are your notes for chapter 18, lesson number 4 on your z-scores and standard normal distribution.